Welcome back to CHD 217, and thanks for joining me once again for Math and Science for Young Children. In each of our sessions, we will be reviewing math, science, and early childhood topics. Our goals for this session include applying mathematical concepts of sorting to a variety of real-life experiences, applying the scientific inquiry processes to the exploration of sink and float activities, and understanding the engage, explore, and reflect learning cycle format of the exemplar activity guides. Make sure you download the note sheet to go along with this video and stick around as we learn more about math and science for young children. Our math topic for this session is sets. A set is using attributes to make a collection. There are different words that we need to know about when we are talking about sets. And of course, the first word is sets. A set is any collection that is grouped together in some meaningful way. Some examples of a set may be plastic toy dogs, counting bears, or colored beads. The next is attribute. An attribute is the characteristic or property used to describe that object or objects. Attributes can be used to sort collections into sets. For example, if we have a set of beads, a collection of beads, we might be able to break those attributes of small down into red beads. So putting all the red beads together. A way that we can take that collection and we can separate it is based on a characteristic or attribute. When we teach about sets, there are three big ideas we need to remember. Number one, attributes can be used to sort collections into sets. So again, the color, the size, or the shape of an object, anything like that. Number two, the second big idea for sets is that the same collection can be sorted in different ways. So if I had a group of sorting bears and the bears were different colors or they were different sizes, I could sort those bears by either color or size. So I could put all the red bears together, all the blue bears together, all the yellow bears together. Or I may be able to take those bears because they come small, medium, and large, and I may be able to put all of the small bears together, all the medium-sized bears together, and then all of the large bears together. And number three, a set can be compared and ordered so that they can be compared by which set has more. Do we have more red bears or do we have more blue bears? They can also be ordered, which means going from the smallest to the largest amount. When you are teaching children about sorting, it's important to remember to make sorting playful. Children like fun. Incorporating sorting into everyday routines, such as how materials are organized in your classrooms, or to cleanup time, snack time, those are all sorting activities. Comment on children's spontaneous sorting. For example, I say you put all the red beads on your necklace. Or, oh, wow, you used all of the cylinder-shaped blocks to build your tower. This really brings home those ideas that sorting is a natural thing that children do during play. Recognize that over time, children's abilities to think flexibly about attributes will also grow. I've explained that we're going to be doing hands-on science activities each week, and we call these activities exemplar activities. Each exemplar activity has a guide that is designed to be an introduction to a science topic for young children. Each guide contains a list of materials, easy to follow step-by-step instructions for setting up and facilitating the activity, suggested questions to ask the children, helpful tips, and background information for the teachers on the specific science content. The exemplar activities are broken down into three areas: engage, explore, and reflect. In the engage section, the teacher is going to introduce objects, events, or questions to engage the students, to access their prior knowledge, and also respond to the learner's interests. The learners will be perceiving and recognizing something of interest in the environment and demonstrating curiosity. In the Explore section, the teacher will create the environment to support and enhance the learner's interest and curiosities. Link the new information to the learner's prior experiences and knowledge, and take note of what the learner is most interested in to expand upon and provide further discussion and new exploration. At the same time, the students are going to be actively exploring objects and phenomena, connecting to prior knowledge and experiences, collecting further information using science and mathematical processes, and building concept development and personal understanding. The next part of the cycle is to reflect. In this area, teachers will facilitate science talks to help learners refine ideas, communicate, construct explanations, and draw conclusions. They're going to model and support using scientific language, ask more focused questions, help learners make those connections, and help learners plan further investigations. And at the same time, the students will be able to talk about what they did during explorations, compare their own thinking to that of their peers and classmates, express their observations, ideas, and understanding in a variety of ways, such as talking, drawing, journals, and creative play. Practice using scientific language and apply learning to new situations. In this week's exemplar activity, we will focus on physical science with the concepts of sink and float. Children make predictions about whether various objects will sink or float, and then test the objects by placing them in a tub of water. They sort and classify the objects into items that float and items that sink. As they experiment, the children make observations about the properties of the different objects and construct explorations about what factors determine if an object is going to sink or if an object is going to float. The underlying science concept for this exemplar activity are that some objects will be ones that float and some of them will be ones that sink, and that different properties of an object, such as the material it's made of, the size, the shape, the weight of the object, will affect whether it will be one that sinks or one that floats. Be sure to take a look at the Engage, Explore, and Reflect sections of your exemplar activity guides, and you can find those in your course reader. As you reflect, think about what you learned about sinking and floating. Do you have any new ideas about why some things float and some things sink? Let's take a look at this video to help us demonstrate the principles behind sinking and floating.
Why do things float? It depends upon two things: weight, how heavy something is, and volume, how much space it takes up. To understand why things float, it helps to understand why things sink. First, let's put a bowling ball in a bucket of water. Let's pause. The bowling ball and the water can't be in the same place at the same time. The water has to move out of the way to make room for the bowling ball. This is called displacement. It means being pushed out of place. So, as the ball goes down, it pushes the water up. Once the ball is completely underwater, it has all the space it needs. Then the water stops moving up. The volume of the displaced water is the same as the volume of the ball. But volume is not what makes the ball sink. The ball sinks because it's heavy. This bowling ball weighs 12 pounds. Water weighs something too. A bowling ball-sized chunk of water weighs about 10 pounds. The water wants to return to its original level, but there's a 12-pound bowling ball in the way. Since the bowling ball is heavier than the displaced water, the bowling ball has more sinking power. Now, what if we replace the bowling ball with something lighter, like a balloon? This balloon is the same size or volume as the bowling ball, but it weighs much less. Now we have 10 pounds of water pushing down on a very light balloon. The water is heavier than the balloon, so the water sinks, forcing the balloon up. Now the balloon is floating on top. Or is it? The balloon doesn't weigh much, but it does weigh something. If you look closely, you'll see it's displaced just a little water. The water it displaced weighs the same as the balloon. Boats work the same way. Boats are heavy, but they are also very large, and a lot of that space is just air. Because boats are so large, they displace an enormous volume of water. All that water is heavy. The boat can't push down more than its own weight, so the weight of the water keeps it afloat. So, to recap, an object floats if the water it displaces weighs as much as the object. If the object weighs more than the displaced water, then the object sinks.
Here's a cool density experiment you can try at home.
Oh,
It's
sorry,
simple.
hold
Take
on.
some water in a beaker.
We
Mix
got
some
to
food color
stop that
for
for a
better
second
visibility.
and
Pour
get
some
that.
honey and it sinks to the bottom.
Stop. Sorry, guys. Sorry. Okay, let's keep going. So let's remember this. This information is for you, the teacher, the facilitator of that science activity, to build your own knowledge. Just in reviewing the video that we just saw, an object's weight does play a role in why some things float and others sink, but it's not the only factor. An object's density, the relationship between its volume and mass, is also a key factor. Therefore, the mass and volume of an object both affect whether it will sink or float, and changes to either of these variables might change the result of the sink float test. Density explains why a ping pong ball floats and a large marble of its equal size sinks. Thanks for tuning in to this session. I hope that you all go on to your course and find out other information that is posted there for you, as well as do the experiments and activities located in your course reader. If you have any questions, please reach out to me. I'm here to assist you in any way possible. See you next week as we learn more about math and science for young children.